Imagine placing Earth next to the Sun, now placing the Sun next to the supermassive black hole at the center of our galaxy. Huge, right? But now imagine placing that black hole next to one so enormous it could swallow all of them without even noticing. Why? How can something become this unbelievably large? And what does it tell us about our universe? For decades, astronomers believed they understood how black holes grow. A star dies, it collapses, a black hole is born. It slowly feeds on gas, dust, even stars. Simple. But there's a problem. Some black holes became far larger than anyone thought possible, far too quickly. Recently, astronomers measured one of the biggest ever discovered, hidden inside a galaxy, nearly 5 billion light-years away. Its mass? Around 36 billion suns. Not 36, not 36 million, 36 billion. But why is that number so important? Because if black holes can grow this large, our understanding of galaxy evolution may still be incomplete. Let's compare. Earth has one Earth mass. The Sun weighs about 333,000 Earths. If the Sun collapsed into a black hole, it would be only about 6 kilometers wide. That's roughly the size of a small city. Now imagine a black hole 10 times heavier than our Sun. Its diameter becomes roughly 60 kilometers, still surprisingly small. Next comes Sagittarius A, the black hole in the center of our Milky Way. Around 4 million suns packed into one object. Already difficult to imagine, but this newly measured giant is almost 9,000 times heavier. 9,000 Milky Way black holes compressed into one. Its event horizon stretches across hundreds of billions of kilometers. If you place it inside our solar system, it would reach far beyond the orbit of Pluto. It wouldn't just dominate our solar system, it will become our solar system. You might think the biggest black holes are also the most dangerous. Surprisingly, that isn't entirely true. Small black holes tear objects apart long before they reach the edge. The difference in gravity between your head and your feet becomes enormous. This effect is called spaghettification, but larger black holes behave differently, much differently. Near the edge of a supermassive black hole, gravity changes more gradually. In theory, you could actually cross the event horizon without immediately noticing anything. You wouldn't suddenly hit a wall. There would be no explosion, no bright flash, just darkness, and no way back. That sounds impossible, but according to Einstein, it may actually happen. Now imagine standing safely millions of kilometers away. The black hole fills the sky, not as a glowing object, but as a perfect circle of darkness. Around it spins an enormous disk of superheated gas, brighter than entire galaxies. This monster contains the mass of 36 billion suns. It controls the motions of countless stars. It shapes an entire galaxy, and perhaps, according to new research, worlds even form around black holes like these. Not one, not hundreds, potentially millions of planets. Entire planetary systems orbiting a cosmic monster. That idea sounds like science fiction, but today, scientists are seriously studying the possibility. Black holes were once thought to be simple, the end of a star, nothing more. Today, we know they shape galaxies. They influence how stars are born. They may even become home to planets. Every new discovery raises another question. If black holes this large exist, could even larger ones still be waiting for us? The biggest objects in the universe are still teaching us how little we know, and perhaps, somewhere inside the darkness, the next impossible discovery is already waiting. The universe is stranger than we ever imagined.